Hello everyone. In this video, we will continue with the force of mortality. In the previous video, we relate the force of mortality at age X to the lifetime distribution of a newborn. We have S0 and F0. And in this video, we will relate the force of mortality at any age to the lifetime distribution of Tx. We have the general force of mortality notation, mu sub x plus t. And here we assume x is fixed and t is a variable. Construct a similar expression for mu x. So here we simply replace the x by x plus t to get the expression for mu x plus t. Since x is fixed and t is a variable, dx plus t is simply dt. And then we factor S0 of x plus t into the product of S0 of x times Sx of t. Factor out the S0 of x. And then the expression in the first term, this fraction, is simply 1 over Sx of t. So we get the relationship between mu x plus t and Sx of t. This expression can also be written as the negative of d dt lateral log of Sx of t. The negative d Sx of t dt is the density function, fx. So mu x plus t equals fx of t over the survival function Sx of t. Further extend this two expressions. Sx of t in actuarial notation is tpx. So here we have the relationship fx of t equals tpx times mu x plus t. And then the expression with the lateral log. Here we will have the similar derivation. Given that we have the force of mortality mu x plus t, we can get the survival probability tpx. So we have the same derivation, and then we can obtain an expression for tpx. This is e to the power, the negative of the integral of the force of mortality mu x plus s, evaluate from 0 to t. By the change of variable, this expression can also be written as the integral of mu s evaluated from x to x plus t. No matter which expression you use, you are integrating the force of mortality function from hx to hx plus t. All right, so we have gone through all the necessary formula related to the force of mortality. Get back to the first expression. We can also express mu x plus t in terms of the actuarial notation. The first expression can be rewritten as the negative of 1 over tpx times d tpx dt. And then the second one is the negative of d dt lateral log of tpx. All right, some properties related to the force of mortality function. The force of mortality function mu x plus t must be greater than or equals to 0 for all x and t. And then since infinity px equals 0, therefore the integral of the force of mortality from 0 to infinity must go to infinity. All right, so we have all the formulas, all the relationships regarding the force of mortality. And then you can see that some are repeated. Okay, these two. The top one is a special case relating the force of mortality to the survival function of a newborn. And here we have the general case. And then similarly for the expression on the right-hand side, these two are very similar. The top one is the relationship for a newborn. So we don't need these two. We only need the top left and then the bottom two. All right, the set of equation or the set of relationship regarding the density function and the survival function, the distribution function. So here, if you are given the probabilities, the survival probabilities or the mortality probabilities, you can make use of this relationship and to get the density function fx of t, or the other way around. And then the set of relationship, okay, in the top right corner here. So here you will use this relationship if you are given TPX or TQX, and then you are asked to find the force of mortality, mu x plus t. And then the bottom one, you are given the force of mortality, and then somehow you need to get the survival or mortality probabilities. And then from that, you can further get the density function. All right, so let's make use of these relationships with a series of examples. The first one, given that Tpx equals 1 minus t squared over 100, and we need to find the force of mortality at age x plus 4 and the density function fx. All right, given Tpx, to obtain or to get the force of mortality, mu x plus t, then this is the required expression. So we simply take the derivative of Tpx with respect to t. So we get negative t over 50 and then over Tpx. And this simplified to 2t over 100 minus t squared. And then we need to get the force of mortality when t equals 4. So we simply substitute t equals 4, and then we get 0.0952. And then to get the density function fx of t, this is the negative of dTpx dt. So we already get the derivative of Tpx, which is negative t over 50. Then the density function fx of t is t over 50. The next example, we are given the force of mortality, mu 35 plus t equals 1 over 100 plus t. And we are asked to calculate the probability that a person aged 35 survives to at least age 95, and the probability that an individual aged 40 dies before age 55. Given the force of mortality, and we need to find the survival probability as well as the mortality probabilities. All right, in part A, we need to find the value for 60p35. Make use of this relationship, e to the power of the negative of the integral. The integral of mu 35 plus t from t equals 0 to t equals 6t. This is the future lifetime. We need to get the value of 60 p35. So we do the integration for the force of mortality from age 35 to 60 years later to age 95. All right, do the integration and the exponentiation. We get the probability 0.6250. And then for part B, we need to get the value for 15Q40. Similar procedure. we are given the force of mortality mu35 plus T. The base age is at 35, and we want to get the value for 15p40. So we will integrate the force of mortality here, mu35 plus T, from age 40 to age 55. So that is from T equals 5 to 20. All right, so do the calculation, and then we get the probabilities 0.1923. The next example, given the density function fx of t equals to 0.002t and then e to the power negative 0.001t squared. And then we are asked to find the expression for the survival function Sx of t and the force of mortality mu x plus t. Given the density function, use integration to get the distribution function or the survival function. All right, so the distribution function is given by this expression by substituting this density function fx of t. The distribution function is 1 minus e to the power negative 0.001t squared. So the survival function Sx of t is simply 1 minus fx of t. So we get the survival function Sx of t equals e to the power negative 0.001t squared. To obtain the force of mortality, the density function fx of t equals tpx times mu x plus t. And we already obtained tpx. Tpx is simply Sx of t. So we can get the force of mortality fx of t over Sx of t. And we get the force of mortality. The expression for mu x plus t is 0.002t. That's it for today's video. In the next video, we will explore more properties of the force of mortality. See you in the next video.